Now we've talked about how motherboard communicates and how they interact with each other yesterday. And today the important topic we will be talking about today is how does voltage circulate in motherboard? Why is it that we place more attention in voltage? Firstly, we need to understand how electricity is distributed in motherboard. Motherboard is more or less like human. If we should share carefully how we are being created, mostly if two lovers will talk, they will say, I love you from my head to my toe. This is trying to tell me that all the creation started from the hair down to the toe, which is the final part. That is the toenail. So that is exactly how motherboard looks like. There is a starting point of voltage in motherboard and there is a ending point of voltage in motherboard. But in the case of motherboard, the air of motherboard, I mean the starting point of motherboard, which is the charging port, if the voltage is not getting to the destination where it is designed to get to, laptop will not work. And where is the starting point? That is the charging port, because the whenever you insert charger in your laptop, we are trying to circulate the voltage on the charger on the motherboard or battery, any one of the two. So where is the final destination? We are talking about the LVDS. That is where the screen connector is. That is the final destination of the voltage. If there is voltage that has to do with display, if you are checking LVDS, that doesn't necessarily mean we'll catch our faults at that LVDS point, because we need to confirm whether everything has worked perfectly before checking LVDS. If system is working or it's about to power, or it has issue of power or power without display, so between the hair and the toe there is problem. That is, there is problem within the charging port, which is the source of the power or battery, before getting to the destination, the final destination, which is the LVDS, that is the connector of the screen. So that means there is problem within that section. So whenever we're talking about motherboard, it's a step-by-step approach. That's just the summary. If one step is not fulfilled, then the next step will not be fulfilled. So if we should look at this diagram properly, we will notice there is arrow. This arrow this particular one is coming from the charging port, and let me minimize this. Okay, so the voltage is coming from the charging port through the adapter, and the other source we have is the battery. So without these two sources, I mean the adapter and battery, without these two sources, it is not possible for your laptop to power, only if it is using other source, whether like solar. In order not to complicate it, if these two sources are absent, that is no battery, no adapter, your laptop is never going to turn on. Here, let me drop this. If you have issue where they say water damage and the board is not working, the most thing that cause the issue is because mostly whenever there is this water damage, there is always no charger there, but the arm there is that there is always battery there, and because there is power on this battery, so it will automatically damage the system. If this battery is faulty, probably the battery is not good and there is water splash. If you did not give any power and the water gets away or get dry or any which way, so 100% your board will work. So what we are trying to figure out here is, without source, laptop will not work. So with these two sources for troubleshooting sake, the aim of us checking board, and let me say the aim of this, for the sake of troubleshooting, the voltage on this adapter is what we are checking, because this is the voltage that need to be circulated. I mean the voltage of these sources are the voltage that need to be circulated. If you remember yesterday when we were talking about generation of motherboard, we have different generation of this motherboard. Okay, let me open one of those yesterday class screenshots. We were talking about generation upon generation yesterday, and when we were talking about these generations, we never mentioned 19 volts that enter this chipset. Whether we didn't mention whether there is 19 volts. Even PCH, we didn't say 19 volts is coming. SIU, the same thing, we didn't say 19 volts is coming there. And why is it that we are saying this 19 volt charger, we should insert it, the 19 volt is circulating on the board? So the point is that's not the way it works. 19 is more or less like our direct light, like the one coming from the transformer. So we need some regulators that will suppress the power of the 19. So if you look at this chipset here, if you look carefully, there is nothing like 19. Look at this one. This one is 1.5 volts. This is processor. This is another 1.05, and this is the main CPU array itself. Even in GMCH here, we have 1.5 volt, 1.8 volt, 1.05, 3.3 volt, 1.05 as well. And we don't have 19 volt here in all of this list here. There is no place where 19 volt is mentioned here. So what is the 19 volt we are referring to here? If you should buy charger out and check, you will see it is written there the voltage the charger is dispensing. For instance, if the charger is dispensing 19 volts, you meet 19 volts there. The way motherboard is working, if 19 volts should enter this board, there is a destination for this 19 volt. This part is called CLR. So that component is current limit resistor. Once the 19 volt is getting there, and that is the point where the adapter voltage and the battery voltage meet each other, and that is where they communicate as per who is going to run this system. Like, okay, charger, are you the one to run this system? Or battery, are you the one to run this system? Let me go for discharging sake. Or charger, let me run this system. You battery, go for charging sake. So this is the point where they both communicate as per how they are going to power the system. So every other part of this system, for them to work, after this 19 volt is present, that is, if it is battery, we have around approximately 11.5, 12 volts, approximately 12 volts. Let's just say 12 volts. We have the 12 volts here. So we won't place attention on there now, because basically with test run, we troubleshoot laptop with charger. So we'll be talking from the perspective of charger. So if 19 volt is present at this point, because every other chipset here, PCH, this is CPU, and this is the graphics, and this is the auxiliary voltage here. All of this, they can work on this high voltage that is 19 volts, because it is too much for them. So we need step down to step the 19 volt down. Just like when you go and get your electronic device and they tell you you are going to need step down. What they are trying to tell you is that the 220 we are using, for instance, in this Nigeria, is not good for the system, for the radio. So you need step down to drop the 220 to the specified voltage. That's exactly how motherboard work. So for motherboard, if 19 volts is present on the motherboard, there is a destination. After it has been circulated everywhere, there is a destination we call standby section. And this standby section, the major function of this section is to convert this 19 volt to a lower voltage that every other section can work on. Why do we call it standby voltage here? This is because it is like a soldier that is ready to fight. So that is, whether we power the board or we don't power the board, the voltage will be present on motherboard. Whenever we are talking about standby voltage, what are the standby voltage? Firstly, they are always the same place, and they're always in the same place, and in most cases they are always controlled by one IC. By the time we are done with components, you will understand this part clearly. At this point, one of them will be 3 volts. I mean, one of the output coil. This is the output capacitor. So the other part will be 5 volts, and this is it here. It is labeled in this diagram. This is 3 volts and 5 volts. These are what we call standby. The main reason why we call them standby is because immediately we plug in our charger, after series of communication within the motherboard, we will treat them one after the other. Immediately we are inserting our charger, these voltages are generating. So 3 volt, 5 volts is the next thing once 19 volt is generated. Why is it that 3 volt and 5 volt is the next thing? This is because it is converting 19 volts to lower voltage, because these 3 volt and lower volts are the voltage that we'll be using on the motherboard to power the rest. Do we all understand?
Oh yes sir.
Ramon, please, what you go the mute.
Ẹ̀gbọ́n ti wà.
Sorry for that. I need to mute that mic. Okay. So to continue, what I'll do now is, where was I? So once 3 volt and 5 volt is present, what is the next thing? Firstly, whenever we are talking about repair, they are not just working for no reason, and they are not just there for no reason. There are 3 questions that are important whenever we are talking about repair. We call them basically 3 why, 3 W's. Or no, 2 why, 1 h. One is why, that is one. 2 WWH, which is when. And the third question is how. How. So these 3 questions here, they are talking about anything happening on the motherboard, anything the manufacturer has done on the motherboard, anything they've done on the motherboard. The first question now, for instance, the question is why. Why do we need 3 volt and 5 volts and the 19 is not going directly? So we've answered it. And what is the answer? Because the other chipsets, they can't work on high voltage, so we need one place where conversion will take place so that their own voltage will be generated. So the next question now is when. So the question is, when is this voltage going to come? That is the standby voltage. That is when the 19 volt is present on the CLR, then it is time for the standby to generate. We should question, how will it generate? This will be generated through this regulator here, the standby regulator. It will be fed through this switch. Actually, these are MOSFET, but for the simplicity, let's just call them switch for now. It will be used to control this section to generate the specified voltage. For instance, if this one is 3 volt, again the same thing will control this switch as well to generate this particular voltage here, which happens to be 5 volts. Let me take this screenshot. So what is the essence of these 3 questions? Is because the manufacturer that designed the board, they don't just design it and place whatever they like on it, so that whereby you can just come on it and do whatever you like on it. So now once 19 volt is present here, which happen to be the first stage, after that 3 volt and 5 volt will generate. So let me sharply screenshot this and we'll continue. I will illustrate this on motherboard after this screenshot. Okay. Okay. Now I'll try and open few motherboards here to explain what I've illustrated earlier on. Firstly, if you are looking at a motherboard, how do you figure which part is the standby section? Normally, let me say the standby IC, we call it power IC too as well. In most cases, firstly, the simplest one is through, if you are familiar with different IC they use for power on motherboard, but if you are still not familiar, there is another thing. Mostly those coils are always beside each other. In this case, this is the two coils here. Why is it that these coils are the main thing we are putting our attention? I will explain, but the simple point I want to illustrate here is, like I've explained in the diagram, if we should look at this carefully, this coil and capacitor, they are together. This coil and capacitor are together for 3 volt and 5 volt once after 19 volt is generated, and this is the IC that will control it. Let's assume this is 3 volt and this is 5 volt. But to be sure, how do you know? You can check in schematic. That is the document you can check in traces. Once we get to schematic, you understand everything clearly, because basically the class is on understanding schematic and how to use it to fix. So for now, for the standby section of this board, this is it here. So to simplify it further, what I'll do is I'll try and go for another coil. There are some coils that are always beside each other, like CPU. We check this one, and this one is standing alone. Even this one is standing alone. These two are together. These two are always for CPU and is always closer to CPU. Another coil again. There is another one with these two here. Indirectly, is standing individually as well. So let's go for the other one at the other side of the board. Sorry for that. Let's check other side of the board again. There is no coil here, and if you should notice here, when I was saying this is the standby section where 3 volt and 5 volt are generated, here there is no MOSFET, there is no those two switches I talked about in the diagram here. This 4 switch, 1 2 3 4, it is not in this image here. If you should flip the board around, this are going to be your MOSFET. That is the 4 switches, 1 2 3 4. So that is it for that part. So another one again I'll open is, let me open another board here in order to give you guys different diversion of it. This is another board. This is compact HP board. Here we have 2 coils here. If you should check here carefully as well, with experience you will get familiar with them later, but basically you can know with the IC number as well. Most of the case it take experience to know with the IC, but the simplest way is to check it in the schematic. If you should check here carefully, these two are closer to each other, and this is the power IC in between. Mostly this power IC will be in between the 2 coils, and with that you can easily identify they are together. These 2 coils here are working for the 3 volt and 5 volt we've been talking about. This one 1 and this one 2. They are the coils responsible for 3 volt and 5 volt. One is going to be 3 and the other one is going to be 5. If we should check. So that is it for that section. So without labeling anything, I can check another one again for better understanding. This is the latest board, SOC chip. If you check here, these 2 are beside each other. So we can say these 2 are the standby IC, but no regulator here, which means if I should flip the board to the other side, the regulator will be there. So this is the regulator here. Can you see it? So this is it, and these are the 4 switches here. That happens to be the MOSFET. This happens to be the MOSFET here. Those are the basic concepts. So later when you get on the board, they will be complicated a bit, but if you should check carefully, it's still the same thing. They just spice it off. So that is it for that section. Going back to the diagram that we've been using to explain things. After 19 has entered the board through the CLR and standby voltages have been generated, what is the next thing? Although before getting to power, there is a lot of process that must have happened. In a nutshell, all of this is summary of how voltage circulate on the motherboard. This is just summary for everything. So that person should please mute his mic. So now, what is the next thing as far as voltage is concerned? Reason why we are placing attention on these voltages in this power distribution is because we should check schematic that I've opened here. If you look at these voltages here, we've seen where 5 volts is getting here. That is the ultimate source of 5 volts. We've seen the ultimate source of 3.3 volts. So we should check this 4 voltage. Ultimately, they are coming from the standby. Although they might have not gotten here by now because they must have not gotten here, but with time they will get here. That is just the source. As far as when these voltages are generated as standby here, they are not entering the board direct. They are just waiting at the point in time for power button to be pressed before entering the motherboard. Just like you having your soldiers at the door and waiting for command to open fire or something. So they are there ready, but they are not starting yet. That is why we call them standby. So that is it for that section. So now it is after you press power button, then you have the following voltages here. After that, you have the RAM voltage. And what is the RAM voltage? Before going to RAM voltage, because we'll be talking, everything we'll be saying here is going to be the same thing. Before going to RAM voltage, we call all these circuits, this IC, 2 switches, 1 IC, and 1 coil and 1 capacitor. I mean something like this. We call it PWM. Pulse width modulator. If you should notice, the same thing is happening with this place. This one has internal 2 switches, but they are all PWM. Even here, the same thing. This is the IC, this is the 2 switch, this is the coil and capacitor. It's also PWM. They are actually using them to generate voltage, and this is one of the ways we generate voltage in PWM. We have linear voltage and we have switching voltage. So here, this is also PWM. Which other voltage again? Again, this is another PWM. Can you now see? They all have the same concept, just with little spice once we get into the board, but basically they all have the same thing. This is all PWM. The only difference there again is they are all these PWM are there to generate different voltages. Do we now understand? ẹni tí audio ẹ̀ bá clear ni kó sọ̀rọ̀ ẹ jọ̀ọ́.
Oh, yes, sir.
Okay. So I quickly hit that point because we are going to repeat the same thing here. Now that we've understand that 3 volt and 5 volt is generating here, so the same process it uses here is what it's going to use here as well. The only difference here is that the time frame after pressing power button, that is when this voltage is generated, and the voltage that will be generated at the RAM section depends on the type of RAM we are dealing with. If it is motherboard that is using DDR2, then we should be expecting 1.8 volts at this coil here. So far this laptop is using DDR2, and at this point too, if it is laptop that is using DDR3, we should be expecting to get 1.5 volts here. And lastly, if it is one that is using PC3L, so we should be expecting 1.35, although it's always the same thing with normal DDR3, but when you are getting 1.35, it means PC3L. And finally DDR4, you should be expecting 1.2. Where do you get these voltages? You will get it at this coil. So all these voltages, even though this standby, where are we going to get this point? Where are we going to check them? We check them at this coil. So now once this voltage is generated, just like it is generated in the standby, here where is the destination of the voltage? The main essence of the voltage is to feed this RAM section. This is the voltage that is used to power the RAM. These particular ones here, they are used on the entire motherboard, these 2 voltages. Generally they are going onto the motherboard. That is their main function. So but regardless whether they are going on the board or not, we should check here. Now we have how many voltage on ground? We have 3 volts, we have 5 volts. Let's assume this is DDR3, we have 1.5 volts. If I should come here, what are the voltages we now presently have now? We have 1.5 volts. Ultimately, if I want to trace this voltage, I know the original source. Another one, we have 3.3 volts. As far as this is concerned, we have this as well. We have this. We have another 3.3 of this. We have 3.3 here as well. Okay. We have each other one again. Let's assume we have this one too. Ultimately, regardless of time, we all know where these voltages are coming from. Even though if it's going to stop over somewhere, we all know the ultimate source now. But when we get to troubleshooting part, we will understand as per when and how each voltage is generated, even though they are the same thing. So back to what I was discussing before, that is this. Ultimately now, we know 1.5 volts is coming from here. After that, what do we expect? We have this voltage here, which is, this is PCH or ICH supply. This voltage is always 1.05. If this voltage is generated, where it is going, this voltage is going to the PCH chipset. This is the destination of the voltage. Where do we confirm? You confirm at the coil. The same process, just like we have coil and switch here, just like these ones too have coil. That is exactly how they are generated. So after that, what is the next thing? After powering board is when you have all these voltages. So what's the next thing here? If there is any auxiliary voltage, for instance 1.8 volts, that one is just there, whether if it is needed to power one particular section just for auxiliary purpose. So this voltage too will also be generated at this section through this particular coil as well, I mean this section. And this one is also going to the board generally as well. So that is it for that part. So followed by voltage that will power the graphics. This will also be generated through this coil. And where is this voltage going as well? This one is getting fed to the graphics as well. So which other one? So finally the CPU voltage will be generated, and once it is generated, where it is going to the CPU chip. The voltage is fed there. So let me screenshot this in case. Actually, I've brought these three, but don't worry, we analyze them one after the other. This is just an intro. So far, so good. We've covered how voltage enter the board generally. So now, let me illustrate one or two voltages on the motherboard. So now, if you should come back here again, let me quickly say this one too as well. So now we've understood how this 1.5 is generated, as well 1.8, this 1.05, and this 3.3/5 volt is generating as even this CPU as well. This CPU voltage, someone's mic is disturbing. Let me correct that, please. Someone's mic is disturbing. Okay. Now corrected. So now you've understood how this graphics voltage is also generated again. So if I should come back here, if I should come back to this diagram, when I was talking about shift set in the previous class, when I said other components are generating voltage only, let me say they are working only to power this shift set. So we should now look this diagram properly here now. I want to believe all this voltage you are seeing here, despite how many they are, we have now understood their birthplace, I mean their source. This is 1.5, 1.8. We now know where this 3.3 is coming from. This 1.05 as well, we know where it's coming from. We've talked about all of this as well. We've not talked about this one, RTC, very, very important. We are still coming there. We've talked about how this one is generated, this 1.5 and 1.05. So do we now understand all this clearly? Ẹnìkan tí máa ìkẹ̀ bá clear kó sọ̀rọ̀.
Yes, sir.
Okay. So nínú diagram yìí tí a bá wò dáadáa. Opened yesterday, and I was making a point when I said every other component on motherboard, they are not doing anything other than supporting those chipsets. And I believe you guys now understand why I'm placing more attention, as in why I'm hammering those chipsets. Let me show that one here. Diagram. Someone asked a question yesterday about chipsets, like why are we talking about them? Someone asked a question about chipset yesterday. That's why are we talking about them? Is the person online?
Minimum very.
Just one reason is interference. Reason why we are hammering those components. So now, what is the reason why? Let me say that is the reason why whenever we are working on motherboard, we are checking those voltage, we are fixing those voltage. Since we can't remove this shift set and confirm under them, so the only thing we can do is to treat the source and make sure the source is perfectly corrected. You understand? And the voltage is more or less like training a child to a point in life, and with time you will leave the child to handle his life. So we will follow the voltage to a point whereby you will leave the rest to the chipset to do what is expected to do. Once we've confirmed that the voltage, we've escorted the voltage to a point where we are sure it's going to the PCH, and once it gets there and it's not working, then it's left to the PCH. There are some faults that are not fixable in laptop. If there is issue with these chipsets, this particular ones, they are still fixable if they are faulty. Once you have your VGA, if you have confirmed they are faulty, or let me say like 15% cases of motherboard is going to be chipset issue. I mean fault of chipset, that there is nothing but to replace them. Some latest one that use on board chip, just like I said yesterday, there is nothing on those board other than the only single chipset there, which is the SoC. You see every other part there, they have been merged together, so it's the only soul of this board. In this case, there is 80% case that, or let me say 20% cases this will be faulty, and once this one is faulty, there is nothing you want to do about the motherboard, only if you replace this chipset. That is this. So if it is this, you can change this one in less than 10-5 minutes. You are done with changing this. But once it is this one, there is nothing you can do, only if you have the VGA chip and VGA machine. So the last faults that are not fixable on motherboard, only if those ones are not too much. There is something we call layers. Actually, they don't write this in all board. Let me check if this one has. We call this one layers. Let me see. This board, it is not written here. They don't write it in every schematic. If you check AXT, it's always there. I'm sure of that. Let me see if there is another schematic here that has it. So on those schematic, I know I have them on my laptop. I just picked this laptop up just for tutorial purpose. So I'm actually waiting for logouts here. That is why I choose not to sketch anything for now. So there is something we call layers. Whenever we are talking about layers in motherboard, layers is okay. This AM camera have started. Let me use my zoom camera. Zoom kí ló tún ṣẹlẹ̀ ló búklẹ̀ níbo yìí ẹjá kan wọ́n bàbá jẹjú mi ó ti yá rere. I'm actually need to wait for the rest, and this is just a free class I've organized class. So those things we didn't. Moto Z3, you are welcome. No. I'm actually waiting for a few people to come on board. Akọ̀tẹ̀sẹ̀ lóde àwọn tó kù díẹ̀ náà ni kò ń ṣe púpọ̀. Yíyà sí púpọ̀. So we're just waiting for a few people to come online. Sorry, it's a low budget video. Actually, it's just a free class organized. Yeah, gosh, crazy. Okay, don't chat me. Okay, I think we can continue. So from here, whenever we are talking about layers, motherboard layers, this is more or less like talking about attaching different step of something. Board to also have layers. At times we used to have like 9 to 10 layers. At least it will have nothing less than 5 to 6 layers. So they will attach this layer just like 5 pages of book. So in this kind of cases, if we have in this kind of cases whereby we have internal damage, whereby the board is shorting internally. So in this kind of case, they are not fixable. Let me say 3% or 5%. So in this kind of case, they are not fixable. Although it's not that much, it doesn't really occur like that. But that is just the secret. Once those ones are short internally, there is nothing you can do. So conclusively, for that reason, it is not all board that are fixable. But at least when you are troubleshooting motherboard, it gives you joy when you get to the source of the problem, whether it is rectifiable or not rectifiable. So because there is that adage when they say let me leave the adage. This is yoruba adage. Okay. Somebody he's just talking about somebody that loses a child, probably a child that died and a child that get lost. So you will keep hoping when the child has lost, but when the child has died, it's easy for you to just forget about the child. You just cry once and you forget about it. So that's the essence. NEPA is doing anyhow, no light. So that's the difference between troubleshooting board to the last pin compared to the fact that you don't know what you're doing on the motherboard. Even though if the fault is not rectifiable, at least you'll be satisfied that okay, you've done the best for the board. So that is it for that part of the motherboard. So it is very, very important for you to understand whatever you are doing on the motherboard in order not to keep gambling wrongly. Even though whenever you are checking and you don't know what's wrong with the PC, you will not be able to complicate the issue because you will understand what you are doing. Because most of the cases I receive in my office, most of the time they will have complicated the issue before getting it to before the laptop get to me. So in most cases, you should understand what you are doing on the motherboard. You will not complicate the issue of the board. For instance, this standby IC, there is this issue it always has whereby it gets warm a bit. Another engineer will change this IC without any troubleshooting. Though it can be the faulty component too, but there is need for you to check one or two things there, like step-by-step sequence to check before concluding whether it is this one. Because in this kind of case, there is a law for this any regulator IC. Once you remove this regulator IC, or let me say if you should replace this IC and this board is getting hot, mostly those engineers, once they remove it and they realize it's getting hot, they can just remove it again and believe if they should insert charger, they will detect whichever one. But that's wrong. Whenever you are troubleshooting board and you remove this regulator, let me use pen. Whenever you are troubleshooting board and you remove regulator that has PWM, that has these switches, MOSFETs, that have this MOSFET. Let me see another one. This one is small. You can see this small one. If you should remove these regulators under must, you must not put charger. If you should insert charger as an engineer, these MOSFETs will get affected. They will short. They will develop fault. Immediately you plug in the 19 volt. If you are using generator, you will detect the kind of short will be affecting your gen because the main 19 volt rail is short. So conclusively, if you should really understand what you are doing on motherboard, you will not complicate the issue of the motherboard even though you don't know. Like these components now, we have different type of components on the motherboard. In fact, they can look alike with each other, but you will be able to understand which one is which. Even MOSFET can look like an IC, and IC can look like a MOSFET, so you will get to understand the difference. Even if you can't fix it, you will know the law as per you must not do this, and this is what you should not do. So that is it for that part. Do you all understand?
Bernice, how are you?
Okay. So I want to believe I've concluded how voltage are fed to the board. So if I try to explain any other thing from here now, it will be more advanced as per how voltage is generated. So instead of doing that, we will leave that for now. And this is what I'm going to do. Before going to that, I will try and highlight all of this in a board. I mean, I'll highlight all this voltage that are generated on a board. So let me go for this Dell board. Look at this Dell board here. Actually, one of those classes we understand this place better whenever we are going for the schematic. Look at this Dell board here. So I want to merge one or two things on this board based on what we've covered so far. Okay. Here, this part is where we have all the coil of this board. That is why I'm placing attention on this part of the board. Firstly, here, how many coils do I have here? That is the main important thing to me first. Okay, let me use pen from here. Okay, this is one. Okay, no, sorry. I want to align this. Okay, let me go for the pen. This is one. This is one coil here. This is another one here. These are for standby, two coils here. We'll confirm them one after the other, just like I've explained in the theory. This is another one here, auxiliary 1.8 volts, making 3 coils. This is another one here for PCH here, just like I've explained in the theory. This one is going to the board generally. So let me keep it branched like this so that you know it's going to the board generally. So this is another one here, 2, 5 and 6, going for CPU. That is voltage that is going to power CPU and CPU. Although this is not the only voltage fed to the CPU, but this is the paramount voltage fed here. Even this one as well, this one is also going to CPU, but this one is going to the graphics parts of the CPU, that is internal graphics part of the CPU. So this one is coming for the RAM. Why we said this one is going for the graphics part is because this particular one, this board doesn't have BGA chip separately. For instance, like the one we did here. This one, this chipset that has this RAM separately. That means if the board does not have that chip, that means that part that is controlling the graphics for the system is inside the system. That is why this graphics voltage is fed to the CPU to power the graphics section of the CPU. So basically, there is one. It's always one IC generating both the graphics voltage and the CPU voltage in this case. So just like I said, they have different blocks. So the voltage is going for the graphics section block of this CPU. So after that, let me screenshot this. If you want to be double sure of all we've highlighted here, so I'll come to the schematic here. Let me close all of this. Okay, so let me open the schematic again. Do I need this? Okay, let me open the schematic. Okay, out. So let me start with this standby. This coil is here. If you should look at this section, this standby section, what is the name of this standby coil location? This number is used to identify the location of motherboard, both schematic and on motherboard. What is the location here? We have PL4601. That is, L here is trying to tell me so yeah, those that are not seeing it clearly can zoom out, that is, they can magnify it on their phone, just like magnifying image. You see what I'm doing clearly at this point. So back to the class. This P here means power, and this L here means coil, that is this component here, that is the abbreviation for this coil, and this number here is telling me the location. So this is coil and this one is location. And LA means power, PWR. So what is here? What do I have here? I have PL4601. PL4601. If I come here and type in PL4601, I will check what is the voltage I should have on this coil. Whether this one is 3 or this one is 5 or this one is 1.05. So I'll confirm here now. If I should punch in the location here, this is it here. Now it has brought me to the area. This is the symbol here. So whenever I talk about schematic, we talk about it carefully. What is the voltage here? So here I'm going to have 3.3 volts here. That is the value of the voltage I will get at this point here, and this is the voltage here, 3.3. Which other one again? I have PL4602. If I should come here, PL4602. So it has brought me where I have this one as well. If I want to confirm what I will have there, so I'll have 5 volts there plus 5 volts underscore power. This power here is trying to tell me something. PWR means power. Most cases when you get power after this voltage here, is trying to pass me information. But for the sake of the class here, I will explain later whenever we are going to whenever we are entering the motherboard. So I'll leave this part here. So when we get there, we'll talk about it carefully. So what we're actually talking about here is locating those coils. So now we are now clear the voltage you have here. We have 3.3, and the second one here we have 5 volts. So what is the voltage I should be getting at this coil as well? I will check what is the location of this coil. This is PL5102. If I should come here now and punch in PL5102. Mistake. 5102. So if you should notice here, the same coil symbol, and I want to zoom out so that everybody will see it clearly. This has given me an idea. If I follow this line, let me extend this a bit. If I follow this line here, this is PL5102. If I should follow the line, what will I have there? I will have 1.8 volts underscore run. This underscore run underscore P. This is trying to pass me message. When we are talking about run voltage, Or let me leave this part, we'll carefully talk about it when we get there. All we are focusing here is identifying those components. So which other one again do I have here? So that is it as far as standby is concerned. This is 3 volt and 5 volts. This is 1.8 volts. Now we understand it on the motherboard. Let's go for another coil here. Yeah, what do we have here? This one is not too clear, so if you check carefully, it's not clear. So in this picture, it's not too clear. So what we are going to do here is, because this component is very very close to this particular one, and I'm sure it's always close, it's always tightened to this capacitor as well. So I can check this component. This is EC5003. I can type it here. EC5003. So this is the capacitor, and that is the symbol of capacitor. Because I'm less concerned of the capacitor here. I only use this to get to my destination. If you check this line here, you can see it is connected here. All this line here on the motherboard is nothing but wire. So this wire is connected to this wire is connected to this. So all these wires are connected. And so before tightening to this coil, so what do I have here? PL5001. If I should come here, 5001. So like I've said, this is the symbol of inductor, that is coil. This is symbol of coil. So and this is the value of the coil here. So now what is the expected voltage here? This is the idea of the voltage. I will get 1.5 volts here. If I should meet 1.5 volts beside RAM, what does that tell me? That means that is telling me the auxiliary RAM. So if I should put 1.35, it won't work, but practically it works sometimes. Just like having system that uses high voltage and I'm not powering with low voltage. Because PC3L RAM uses 1.35. So that is it for this section. So but the designed one for this board, you will get the voltage at the coil here. So that is it for this section. We've checked this, and we've confirmed this 1.5 as well. So that is, if I should come back to my picture here, we've confirmed how these RAM voltages are generating. We've confirmed this standby as well. We've confirmed 1.8, and we have this 3 left. Which other one do I have here? Okay. This is another coil here. So what is the location of this coil? This is PL4902. PL4902. This is coil symbol, and it is written here coil. This is the value here. What is the expected voltage here? This is 1.05. If I'm getting 1.05 here, where is the destination? I'm sure once I have 1.05, this is the destination of my 1.05. So that is this for this section. Another section again, that's mean by this is another coil. Reason why they are using 2 coils for this CPU is only because this CPU we need very huge power, current. So therefore they are using these 2 coils to support each other in order to power the CPU, and it's always the last voltage to be generated on the motherboard. So practically this statement is not too right, but theoretically that is the message. These 2 coils are always together because this CPU coil, it's working on very high current. So these 2 coils are connected in order to increase the power. So the power dispensation will be high here. That is why they use 2 coil here. And if you should notice, it's always connected with output coil as well. And all this green part is trying to tell me wire connection. Look at the output here. This is it here. Follow the line. They are always connected here. Even this one as well. As you can see, they are connected here as well. And if you should check from here, this is the same wire. You can see they are connected. So these small ones, these are the ceramic capacitor. This small ceramic capacitor, one part on supply and one part on ground. You can see this is ground, so we've not done component. Don't let me disturb your brain with that. So this part is the ground. As you can see, that is why these two lines are insulated here. So in a nutshell, what we are trying to explain here is, whenever we are talking about CPU, the current of CPU is always high. That is why they use two coils for CPU. So PL4813, if I should come here, PL481412. This is 14, PL4814. And here, this is the coil here, PL4814. And this is the PCC CPU core. And what is the voltage? They call it VCC_core. That is the voltage that is going to power the CPU. Reason why the voltage is not specified here, like no fixed voltage here, is because this particular section has no fixed or specific voltage. The voltage at this point fluctuates based on the working of the CPU, as in based on how much the laptop is working. If the laptop work to a point, I mean the motherboard work to a point, let me go to the other side of the board. I'm looking for the IC. The IC always has some pin that it's used to sense how much this laptop is working, so that through this pin they will communicate with the CPU. Communication will occur in between the CPU and the IC as per how much power it is needed to calibrate the output voltage. So once this communication is taking place, it enables the output to fluctuate. So what we are trying to explain in a nutshell is the output is not always fixed. So the output of the voltage depends on how much the laptop is working. So there is no fixed voltage. That's just the nutshell. There is no fixed voltage for this CPU core. Even GFX as well. Although the fluctuation of that of graphics is not that much, but also it has no fixed voltage as well. So here we've talked about how this is generated in our diagram. Now we've talked about how this is generated, You can see how I'm locating them on schematic and motherboard. You can see how I'm locating the expected voltage on motherboard, even though we are not familiar and based on experience. So now, going back to where we were illustrating it before. Here, we are clear with these coils, and this is the only leftover coil. So therefore, this will be for graphics. So if I have no idea before, if I want to confirm, this is the location here, PL5301. So if I should come here in the schematic, I will punch in PL5301. So what is the expected value there? Like I've said earlier on, it has no fixed voltage as well. What they are trying to tell me by this CPU is that this voltage is inside the CPU, is going to the CPU. And where is it going? It's going to this graphics part of the CPU. And where in the graphics part, the core section of the CPU, of the graphics. So all these writings always have meaning and explanation that will be carefully explained. But we'll take them step by step. So another thing I have not explained here, let me quickly conclude that. Here, we've all identified all these components here. Let's assume I don't know which coil is for which one here. We've all know how to identify each coil on the motherboard. So going back to the previous image I was using, I said 19 volt is going to the entire board. When I said 19 volt is going to the entire board, the question is, here now I said all this section here they can work on high voltage. That is why we need this standby voltage to generate lower voltage that will be used to power the rest. Don't you notice that is contradiction? So let me ask the audience from here. Alabi Mumini.
Baba.
Sheba Abere. So I want to pick someone here so that I'll flow with the person. I have one or two questions at this point here. So I want somebody to signify. So I don't want this guy, Mr. Oki. I want someone else. Somebody has specified here, Femlek. Okay. Now, here, when I was explaining as at the beginning, I said these ones here, when I was talking about why, when, and how, I said these other sections can't work on a high voltage. That is why we need this one to power the rest. Abi?
Yes.
At the same time, I said 19 volts, once it is generated, it is going everywhere on the motherboard, and this is the part here that we can all see is going to the motherboard. What happened? So is it convincing or not?
Actually, it was convincing because as of 19 volts, ó lọ sí orí board ẹ ti padà yànnàná pé a ní ló fi fún iye àwọn components láti to reduce the voltage for someone.
Okay. Let me carefully explain it better here now. So when I zoom this place out, I remember I've not explained it better.
Yes, sir. To my own view, ọ̀nà tí òun gbà wà confused mi pé 19 foot ló wá direct, but ó ti padà ó split eléyìí tó lọ sí gbogbo section kọ̀ọ̀kan. Tá a bá padà accumulate everything, ó máa padà arrive sí 19 foot yẹn.
No. So let me explain carefully here. So I'll explain in this diagram. When I was saying all this IC cannot work on high voltage, I don't mean or let me say, when I say 19 volts is getting fed to the entire board, that doesn't mean it's coming inside the IC, the regulating IC itself. Let me use schematic to explain. I'll just open the section and explain. Okay, this is one section here. This is a section here. What is the generated voltage here? If you should check here carefully, this is 1.5 volts here. But here, this is 1.5 volt, but here, the place where 19 volt is getting fed is to the top MOSFET, that is this top switch. 19 volt is not that the 19 volt is getting fed to the IC direct, else it's getting fed to the top MOSFET of those two MOSFET. Back to this image here, if we should say 19 volt is getting fed to this part, so the part where the 19 volt is going is the top MOSFET of these switches here. It's coming here, not the IC. Even this one is coming here. That is why there is always capacitor connected there. Or let me correct here. Let me use lower part here. Okay. That is why you always find capacitor very closer to it. This is it here. Which other one? Let me use this two. The top MOSFET is the destination of the 19 here. Whenever we say it's going to every section, aside from the vehicle. But let's just leave it like that for now. So now once the 19 is getting fed here, so this particular IC we get this particular IC we use that avenue to generate the 3 volt and 5 volt. Remember, 19 is coming to the standby IC direct on its own. Every other we are talking about every other section here, not standby basically. I'm looking for a section here. Okay, we are at 1.5. Okay, this is the section here. So look at this place. This is where the 19 volt is getting fed here before it generates 1.5 volt. If you should look at this place, these are the two switches here. These two switches here. I'm just using standby as a case study. So standby 19 is getting fed direct to standby. So why it is written here 1.5 volt underscore power underscore SRC? This is the type of name that are given to voltage. For instance, now this is part of name that is given to CLR part. I mean, we can call it B plus, CLR, Vim, power SRC. You can call it SRC. So here, this is the real name, power SRC. This 1.5 here is trying to tell me this is the 19 volt that is getting fed to power 1.5 volt. It must have passed through a component, probably fuse or coil. Can check if you download this schematic, you'll find it. So what is trying to communicate to me here that we have 19 volts here, and this is 19 volt that is used to generate this voltage. So do we all understand that part now? So I've not been checking my time. We need to round off this class. So at this point, very good mo ti ṣàlàyé bí iná ṣe wọ orí mọ́tò. I want to believe at this point I've explained basic concept of how voltage is distributed on the motherboard. So we are going to attend this course gradually, and later we'll tune the tempo up, and the explanation will be more detailed about each section. But with time we'll get to talk about one particular section thoroughly. So concerning their process, how, when, steps, everything, we'll talk about them carefully. Like this section now is over 4 hours class to 4 to 3 hours class to fully understand this section in different dimensions. But we are taking it gradually. We are taking it like summary part now, so that you get familiar with every section now. Do we all understand?
Yeah.
So listen, so that we can round this class off. Does anybody here have questions based on what we explained so far today? So do you have anybody that has question? Màá yìn tí ní next topic tá máa ṣe lọ́la. Kí ni àwọn nǹkan tí ò yé? Okay. Any question? Right on. Mo ń gbọ́. I'm happy to you. Your mic, you have to be mic you there.
Sorry.
Okay. Tell me wọlé mi mic ò kí ò dá. Ẹni tó bá ní question kò sì gbìn tó bá rẹ̀ sí question kí ni end class.
Ṣé mo lè béèrè question bá?
You are good to go.
Pẹ̀lú.
Based on this person question, He said based on how voltage is entering the motherboard as per battery and adapter. He said, what are the circumstances that will rise whenever we have issue that probably this system is powering on battery but it's not powering on charger? That is the question. So based on that question, I'll answer. Based on your question, so if we should check carefully, we said there is a point where adapter and battery voltage meet each other. Look at, let me use pen here. Look at, okay, all these lines here, they belongs to a section. All these lines here, this is for the battery part, and the other one I drew is the adapter part. So here now, there are some parts here. If firstly from this point here to this point here, we can tag it as point A. Let me cancel this so that we have enough view. So from this point to this point, we can tag it as point B as well. From this point to this point as well, we can tag it as point C. So if there is problem within point A, this point A, there is so the laptop will not power because this is the section where charger is controlling. So now, if there is problem within point B, that is this point to this point, this battery to this destination, the laptop will not power on battery because this is the part controlled by the battery. If there is problem from this part to this part, which is the C part, so whether battery or adapter, the laptop will not power because from this part to this part, they are the same part. I mean they are the same rail, but here they are working individually. If A is 40, B is 40, they won't work based on their parts. So that is it. So that is it for that section. We have less than a minute to round up the class. Clear, but
it's better.
Question
ẹjọ lórí àwọn pẹ́ẹ́jì táwọn yẹ̀wò yẹn ẹsẹ̀ méjì ni ó wà níbẹ̀ ṣé voltage balabala pọ̀ tó lọ́la àwọn bá ní àkóso.
This person said on these coils we are checking, we have two legs. Is it mandatory we have the same voltage on the two pin? Unfortunately, we are out of time for the scheduled time for the class, and this is a very, very interesting question I would love to answer because practically it's different. So people are begging for login. Mako down question or kini kan tí bá ti login. I will end the class here and I will answer the question in the next login.